Welcome everyone to today's presentation on building in a bushfire-prone area. This is presented on behalf of Think Brick Australia. So just some background information before we begin. This presentation will go through relevant standards such as AS 3959, construction of buildings in bushfire-prone areas. We will look at how to determine bushfire attack levels and the corresponding construction requirements through the use of this standard. Given the bushfires New South Wales and Victoria have experienced in early 2020, houses in bushfire-prone areas must be carefully designed and constructed to reduce the risk of ember attack, radiant heat, and flame contact. Bushfires are unpredictable and are a common event in Australia. Houses in bushfire-prone areas are assessed and given a bushfire attack level, or BAL rating. AS 3959, construction of buildings in bushfire-prone areas, is the main standard that covers the bushfire safety requirements of a building in a bushfire-prone area. It provides a simple and detailed methodology for calculating the bushfire attack levels. AS 3959 recommends the use of masonry, as it is non-combustible and has excellent insulation properties. For walling, brick cavity, single-leaf brick, and double-leaf brick shall be used. The bushfire attack level is a measure of the severity of a building's potential exposure to ember attack, radiant heat, and direct flame contact, and is measured in kilowatts per meter squared. It provides the basis for establishing the requirements for construction to improve protection of building elements from attack by bushfire. Here we have a table outlining the different bushfire attack levels, ranging from low to FZ. The threats affecting bushfire attack levels include ember attack, burning debris from wind-borne embers, radiant heat, and direct exposure to flames from fire fronts. There are two methods in determining bushfire attack levels: the simplified method, which can be found in Appendix C of the standard, and the detailed method, which can be found in Appendix B of the standard. We will be looking at the simplified method in this presentation. The following tables will be used to determine bushfire attack levels. Here we have a table that represents the fire danger index for different regions in Australia. As you can see, regions with different biomes such as New South Wales and Victoria have different fire danger indexes to accurately depict fire danger potential. Here is a table that identifies different classifications of vegetation. Typically, a forest vegetation classification poses the highest risk to fire danger due to their size and foliage density. Another factor that we need to consider is the distance of the building from the classified vegetation. The distance of the building shall be measured from the edge of the site to the edge of the classified vegetation in the horizontal plane, accounting for any slopes present. The distance is represented in the adjacent diagram from point B to point A. Effective slope of the land under the classified vegetation shall also be taken into account. Effective slope refers to the slope under the classified vegetation in relation to the building. It is determined on the basis of the fire moving towards the building and the rate of spread of fire. If there is more than one slope, each slope shall be individually assessed and the worst case bushfire attack level shall apply. On the right, we can see different orientations of effective slope relative to the two buildings. This is the table we use to determine the overall bushfire attack level based on the aforementioned parameters. Firstly, we determine the Fire Danger Index, or FDI value, to find the appropriate bushfire attack level table. Here, we determine the bushfire attack level for the three categories: vegetation, distance from site, and effective slope. We then select the highest bushfire attack level, which applies to the entire building. Any adjacent structures that are within 6 meters of the building shall be assessed separately. Once we have calculated the bushfire attack level, we determine the corresponding construction requirement. Components such as subfloor supports, floors, walls, external glazing elements, doors and roofs shall be designed accordingly, just to name a few. Building materials and components must be fire tested to determine if they are fit for use. Any element of construction shall satisfy the test criteria set out in the AS 1530 series. For bushfire attack levels between 12.5 and 40 kilowatts per meter squared, AS 1530.8.1 shall be used. For bushfire attack levels of FZ, which is greater than 40 kilowatts per meter squared, AS 1530.8.2 shall be used. We will now go through a worked example on how to determine the bushfire attack level. We are given that the site is situated in the general New South Wales area. The flame temperature is measured as 1090 Kelvin. The site's effective slope of land under the classified vegetation is 0 to 5 degrees downslope. The vegetation classification is forest, and the building location is 15 meters from the edge of the classified vegetation. Using Table 2.1, we find that the fire danger index for the general New South Wales area is 80. Using Table 2.3, we are able to identify the vegetation classification. Figures 2.4 A to H provides a visual representation of the chosen vegetation type. For forests, it may range from tall open to low open. Using the values found from the tables and the given values, we are able to determine the bushfire attack level in Table 2.5. In this case, we find that the bushfire attack level is FZ, or flame zone, which is the highest level of bushfire attack. From here, we are able to determine the construction requirements for a flame zone bushfire attack level, which can be found in Section 9 of AS 3959. Here is the list of all the building elements that must meet specific construction requirements. As the bushfire attack level is determined to be flame zone, all building elements shall be tested in accordance with AS 1530.8.2. In Section 9.4 of AS 3959, full masonry or masonry veneer walls are recommended for exposed components of external walls. As mentioned before, masonry is recommended due to its non-combustible nature and excellent insulation properties. The Association has also curated a Building in Bushfire-Prone Areas manual that provides guidance and design requirements for building in a bushfire-prone area. It contains a lot of useful information on design and construction requirements, and I highly urge you guys to check it out. If you have any other questions regarding building in a bushfire-prone area, please don't hesitate to contact the Association, and we will be more than happy to help you guys out. The Association also offers a wide range of free resources available to the public, such as technical manuals, research papers, and case studies. The Association also has a technical hotline where we can answer any of your brick or block related inquiries. Should you have any questions about the design and construction of brick or blocks, please feel free to give us a call on the technical hotline. This concludes today's presentation on building in a bushfire-prone area. Thank you for your time, and we hope you enjoyed today's presentation.